Hello and welcome back. Today we are going to talk about vector fields. Now last year in single variable calculus we talked about something called slope fields. Vector fields and slope fields do have a lot in common. I mean, there are some small differences and we'll talk a little bit about those later on. But right now let's kind of go into what a vector field is. Now a vector field in 2 or 3 dimensional space is a function called f hat. Now, some books will have this bolded. It'll be like a big old F. Some books it'll just be bolded. F, a bold F. But we're going to use f hat in here. So a vector field is going to assign to each point a 2 or 3 dimensional vector given by f hat x, y in 2 dimension, or f x y z in 3 dimension. Now you might be familiar in 2 dimension. If this gives me a vector, we can kind of think of this as similar to slope in 2 dimension. And as we said, they are very similar to what we did last year in BC calculus. So let's go ahead and sketch some 2-dimensional vector fields. Very easy to do. So what we're going to do is we're just going to pick a bunch of points. So we're going to use the following point. I'm just going to go, so if I were to graph a vector field here, let's just do all the ones only. So I will find the vector field at 1, 0. Now you can notice this is the very same thing as what we did in BC when we did slope fields. And if I plug this in, my x value is 1, my y value is 0. So if this is my vector field right here, remember this part right here, that's my change in x's. This part right here gives me my change in y's. So if I just plug these in, my x value is 1, my y value is 0. So that's going to give me 0i, because y is 0, so 0i plus 1j. And so what this is telling us is that this is moving 0 in the x direction, up 1 in the y direction. So this is moving up here. Now, the big also difference between vector fields and slope fields is that a vector has magnitude. So I'm going to go ahead and get the magnitude of this vector. And it's not too hard to do. Square root of 0 plus 1 is just 1. So what this is telling me is that we are going at the point 0, 1, we are going up 1 unit. So it's just going up 1. Also notice the big difference in the slope field, we would have arrows in both directions. But remember, a vector field has direction. So this is going up 1 unit. So let's try another one. Let's try 1, 1. If we did that, we would get negative 1 in the I direction plus 1 in the J direction. So let's think, what's that going? This is going to the left and up. So it's going to the left and up, kind of like this. Now again, I do want its magnitude, and that is going to be the square root of 2. We can figure that quickly. So at 1, 1. Now notice, 1 is slightly less than root 2. So I need to make this one a little bit longer. This one's going to be a little bit longer than the original one because we have to represent that magnitude. So I'm making it a little bit longer. That looks about the same size. So let me go ahead and erase that and try that again. A little bit longer. There we go. And I just keep going. So let's keep going here. Let's do the vector field at 0, 1. Well, that's going to give me my x value is my x value is 0, my y value is 1, so it's negative I plus 0j. So which way is this going? This is just going to the right, or to the left, so it's going this way. And again, its magnitude is 1. So at 0, 1, we're just going to the left, 1 unit. Oops, don't make it too long. Come on. There we go, just do that, I'll cheat. Now, it's got to be about the same length as 1, so we got to try to make it 1 unit. We'll show you a secret later on about how they don't worry about the same lengths. And I just keep going. What about at negative 1, 1? So if we did negative 1, 1, and I'm going to write these as a vector now. So my x value is, my y value is, so we get set -1, -1, sorry, -1, 1. That's going to give us, what's that going to become? My y value, so we get -1, -1. Well, which direction is this now going? It's going left and down, so like that. And it also has a magnitude of √2. So here it's going left and down, and it has a magnitude of about √2. I keep going. What about f of -1, 0? Well, that's just going to give me 0, -1. Well, that's just going straight down. Whoops, that's a weird looking way to go down. And we'll have a magnitude of just 1. So here it's going down 1, like that. And I just keep going. What about -1, -1? Well, that's going to give me a vector of 1, -1. So which way is this going? It's going to the right and down. So right and down, whoop, like so. And its magnitude is going to be √2. Right there, √2. And my next one, what about 0, -1? Well, that's just going to give me 1, 0. So this is just moving to the right. And it has a magnitude of 1. And our last one, 1, -1, and that's going to give us 1, 1, and that's moving up and to the right. And this will have a magnitude of √2. It's good to list out the magnitudes. We'll talk about that in a second. So it goes like this. And so let's take a look here real quickly. Now notice, what shape does this kind of make? Right here. And if you said a circle, you're doing pretty good. So if I look at just make this as a unit circle, if you notice, this gives us a circle with a counterclockwise direction. So this is a circle with a counterclockwise rotation. So it's giving us a direction that we are moving here. Now, one thing you might notice when I drew my circle, I didn't hit all the points that we used. And that's very interesting, right? But also notice all the points don't have the same length. So quick note, they're not all the same length. Well, what does that mean? Well, if they're not all the same length, that means we would have multiple circles, and that's because they are in different circles. They are not the same circle. In other words, in this case right here, they're not all going to be on the same circle. And it's very much similar we did slope fields, where a slope field gives us every single possible function. A vector field gives us every possible function as well. So even so, some of these points right here won't all be on the same. And we're going to talk more about the direction just a little bit, okay? All right, so let's take a look at number 2 real quick. All right, so here we go. So we have f of xy is 2x minus 2j. Now notice this 2 right here. This is a constant, right? This is a constant. Therefore, we can say the change in y is always -2. So if I just want to graph my same points right here, f of, let's do, and we'll just do the same points we did before, 1, 1, 1, 1, right here. If I did 1, 0, well, that's just going to give us the vector 2, -2. Be careful of the magnitude. The magnitude here would be the square root of 8. So what does that tell me? At 1, 1, which way are we going? We are going to the right and down. So at 1, 1 goes right and down, and it's going to be a magnitude of √8. So it's going like this. If we did 1, 1, we would get 2, -2 as well. So again, so at 1, 1, it's the same direction. It still has a magnitude of √8. If we could keep going, rocking around the clock, 0, 1, that's going to give us just 0, negative 2. So remember this, which way is this going? This one's just going straight down, right? But it has a magnitude of 2, which is less than this one. So here we have a magnitude of 2. Now, here's what we tend to do. Sometimes we can keep it the same length. So because if we kept drawing, if we drew these their actual lengths, it gets very messy. So sometimes what we do is we make the vector thicker. The thicker the magnitude, or the thicker the line, the vector, the longer it is. So sometimes we use thickness. So what we might do is I might make these a little bit thicker to show length. In order to compensate for that length right there, we'll make these vectors a little thicker. And this one, I can draw it the same length now, but it's not going to be as thick right there. So sometimes we use thickness to represent length right there. All right, and I can keep going. What about negative 1, 1? Well, that's going to give me negative 2, negative 2. So this one has a magnitude of, again, root 8. And we're going to go right over here. And again, because the same length is there, I'm going to try to make it the same width. Make my vectors the same width right there. And the same thing over here. We got negative 1, 0. And if we did negative 1, 0, we would get, what's that going to become? Negative 2, negative 2. Same direction, magnitude of root 8. So it's going to look like this. Matter of fact, same thing here. If we did negative 1, negative 1, same thing. We get negative 2, negative 2. So let me scroll up here. So our magnitude would equal the square root of 8 again. Try to make it the same thickness, mess that up. But you can hopefully get the idea. And then if we did 0, negative 1, we're going to get 0, negative 2, which has a magnitude of just 2. So again, same length, but I'm just make it a little bit thinner. Right there. And let's see here. Let's do the last one. 1, negative 1, and that's going to give us negative 2. Sorry, positive 2, negative root 2. Our magnitude is root 8, and again, we're just going right and down, so it's going to kind of look like the following right there. And there we go. Alright. And there's how we graph it. So a couple ways you can graph these. One, you can try to draw them different lengths, which is okay, the magnitude. Magnitude is important here. Or two, the bigger the magnitude, you can make the thicker the vector arrow. But either way, magnitude is important. Direction and magnitude is important on these, okay? All right, I'll see you in the next video. We'll take a look at some more examples. I'll see you then. Bye-bye.